In this video, we're going to look at U substitution again, but we're going to look at a problem where finding or looking at the indefinite integral, taking the indefinite integral, a problem where the U is not so obvious. What I mean by it is, let's look at this problem. Let's say if we're taking the indefinite integral of square root of 7x plus 9 dx. Now, from this problem, you might think that 7x plus 9 is going to be our u. But where on this problem do you see its derivative? Say if we had u equal to 7x plus 9. Now if we took du, it would be just 7 dx, because the derivative of 7x is 7 and the derivative of 9 is 0, so it would just be 7. And then the dx on the other side, because we need it in differential form. So this is going to be our du, but we don't see a 7 anywhere here on the original problem. But what we can do is actually rewrite this problem so we can have a 7 on the outside. Now, remember, we can always add scalars, like values that go outside the this integral sign here and come back in and be multiplied back in. Okay, so let's go ahead and rewrite this problem to something a little bit different. Say if we had the indefinite integral of 1 over 7 times 7 and the square root of 7x plus 9 dx. You can see I rewrote the problem here. This way we have both the 7x plus 9, which is u, and its derivative here, 7. So if we pull out the 1, 7, since it's a scalar, it can be pulled out of the function of the indefinite integral function. So what we have here is if we pull out the 1, 7, we would have 7 here, and the square root of 7x plus 9 dx. Now this problem looks a lot easier to work with since we have both the u, which is here, and the du, which is these two here, the 7 and the dx. So we have both our u and du. So we can go ahead and rewrite this down here. We have 1/7 and the antiderivative, or indefinite integral, of square root of u, which is what 7x plus 9 is, and du. And we can go ahead and rewrite this as to make it easier. We can have 1/7 indefinite integral of u to the 1/2 power. If we change that square root to the 1/2 power, it makes it a lot easier. And then du. Now if we had that, we're going to take the antiderivative, or indefinite integral. So what we have is 1/7 times, if we take the antiderivative of u to the 1/2 power, it's going to be u plus 1/2 plus, or 1/2 minus 1, 1/2 plus 1, which is 3/2, and then n at the bottom would be 3/2, and plus a constant. But we can actually rewrite this here to bring the 3/2 up to the numerator. So what we have is 1/7 times 2/3, because remember we can multiply the bottom, which was 3/2, here, and if we flip it, we can bring it up to the top. So 2/3 times u to the 3/2 power plus a constant. And we can also go ahead and distribute the 1/7. So what we have is, let's see, it would be 2 over 21, I believe, u to the 3/2 power plus a constant, because we're multiplying two numbers, and numbers are going to be constants. So this is our indefinite integral. Now, we're not quite done yet. Well, this is the basis of it, but don't forget, we need to go back and resubstitute the u, which I almost forgot to do. So what we have here is 2 over 21 u, which u is going to be here, 7x plus 9. So 7x plus 9. And then the square, take that to the 3/2 power plus a constant. And that is our final answer, which is same thing as that, but we just resubstituted back in the u, and that's how we do a u substitution on a harder problem.